Hi, my name is Tiffany Snow.
Hi, my name is Kwong. In this presentation, Tiffany and I are gonna introduce the Hubble Space Telescope with general structure, what went wrong with it, and how it was fixed. When we think of the Hubble telescope, we think of the incredible, the discovery of distant galaxies new and on, the ability to see further into space than ever before. Before starting with its failure, I talk a little bit about his history and the concept. It was carried into the orbit by Discovery Space Shuttle in April 24, 1990, from Kennedy Space Center and remains in operation today. The first serious idea of an orbital observatory in space came about in 1946 by a researcher and professor at Yale University, Lyman Spitzer. He guessed that a telescope in space would give great advantages, because a telescope in space can observe phenomena that might be completely missed by land-based telescope. Also it can get rid of blur due to the Earth's atmosphere as well. This picture showing two astronauts setting up the telescope in space. This is the general telescope blueprint. It has two main mirrors. They are primary mirror and secondary mirror. The primary mirror is a disc of glass 2.4 meter in diameter, coated with a very thin layer of aluminum. Well, what went wrong with a primary mirror? When a glass is polished, small amounts of material are worn away, so by selectively polishing different parts of a mirror, the shape is altered. The flawed shape was due to a mirror needed in the construction being off by 1.3 mm.
NASA had a backup mirror manufactured by the Kodak Company due to the continuous delays and overspending by Perkin-Elmer. It was determined that replacing the flawed mirror would require bringing the Hubble telescope back to Earth, which would be extremely costly and therefore was out of the question. It was then decided that the flaw would be corrected with lenses created by duplicating the flaw in reverse, much like spectacles. These lenses accompany the relay mirror surfaces of the Wide Field and Planetary Camera 2, which was already scheduled to replace the current camera system. This corrective system was named the Corrective Optics Space Telescope Axial Replacement, or COSTAR. The COSTAR system was implemented by astronauts during a scheduled maintenance trip in 1993. By 2002, all instrumentation that required COSTAR had been replaced by instruments each with their own corrective optics. The COSTAR system is now at permanent display at the NASA Museum. These images show the dramatic difference before and after the COSTAR replacement system.